So in this lecture, we're going to talk about radical equations and functions. So mostly we're just going to focus on radical equations. The functional aspect of this, you can use previous things that we've looked at to apply similar things. So we want to be able to solve equations that have radicals, such as this one right here. So how do we do that? Well, the basic procedure is to isolate the radical on one side of the equation, bring everything else to the other side of the equation. So already we have the radical over on this side. So now what do? Well, we want to get rid of the radical. And so we sort of have to do the opposite effect of what taking the square root is, and that is to take the square. So what we're going to do is we're going to square both sides. So isolate radical, which is done, and take square of both sides, right? Because we already know that both sides are equal, so if we square both sides, then that will also be equal. So the square root of 3x plus 1 quantity squared is equal to 4 squared. And now you see, why would we do that effect? Well, the square root and the square will affect the square of the square root will just give us what's under the root. So this will be 3x plus 1, and that's equal to 16. And then now this is like any equation that we've already encountered. So what would we do? Well, we'd subtract the 1 over to this side. So subtract 1. And we have 3x left on the left side equals 15. And then we'll divide by 3. And then we'll have x is equal to 5. Okay, so just like we've always been doing when we're solving equations, like here, we have an addition. So to undo the addition, we do the sort of opposite operation, which is subtraction. So you see squaring and square rooting, those are essentially opposite operations of one another. And that's how we get rid of the roots, okay? Moving on to our next example, we have the root of 3y minus 1 equals 2. Now we already have the root isolated on one side of the equation, so we can square both sides. So we will have the square of 3y minus 1 equals 2 squared. So the square root squared will just give us what's under the root is equal to 4. Then we will add 1 to both sides, because now this is an ordinary equation. We have 3y equals 5, and then divide by 3. And y is equal to 5 divided by 3, so 5 over 3. And our next example, we have the square root of 3x plus 1 minus 4 is equal to 4. So at this point, we could square both sides, but it will actually be a little bit more complicated than what we want. So the basic procedure is to isolate the square root. Okay, so what we're going to do is, before we square, let's bring the 4 over here. So let's add 4 to both sides. Okay, and then we will have the square root of 3x plus 1 is equal to 5. Okay, and then now we will square both sides. So the square of this is equal to the square of this. And then we'll have 3x plus 1 is equal to 25. And then now we will solve this equation. So subtracting 1, we have 3x equals 24, and then now divide by 3, and we will have x is equal to 8. Moving on. Okay, now if you happen to have something that isn't a square root, like this one is a fourth root, if you have an nth root, isolate this to one side, then take the nth power of both sides. Okay. So we already have it isolated to one side, right? We have this fourth root. All of this is isolated to one side. If not, you would bring all the extra stuff over here. And then now, to undo the fourth root, we will take the fourth power. Okay, to the fourth power is equal to 3 to the fourth. So then what will this be? Well, we'll just get what's under the root, 4x plus 1. So that's actually, it looks crazy at first, but by taking the fourth power, it becomes much simpler, right? And then this, what is this? Well, this is 3 squared squared. And we know that that's 9 squared, and that's 81. Okay, so we have 4x plus 1 is equal to 81. And then subtracting 1, we'll have 4x equals 80. And then divide by 4, we will have x is equal to 20. All right, now what about this one? Well, we have a root involved. We want to get rid of that root, and we want to try to solve the equation. We're trying to solve for a in this situation. That's the variable. Now, do we already have the root isolated to one side of the equation? Well, the answer is yes. So how do we get rid of this root? Well, it's a square root, so we're going to square both sides. So we will square this, and then we will have to square the right-hand side. So we'll put the entire right-hand side in parentheses and then square just to make sure that we do that correctly. So this just becomes a plus 2. But how do we square this? Well, we're going to have to FOIL that out, right? So that's a plus 2, a plus 2. So this is a plus 2 is equal to, now foiling, this will be a squared, right, first, plus outside 2a, plus inside 2a, and then last plus 4. And then simplifying, we have a squared plus 4a plus 4. So how do we solve something like this? Well, it looks like we have a quadratic, right? Or, you know, just some polynomial. So what did we do before? Well, we brought everything to one side, and then we tried to use our property of 0, right? So we will subtract the a, and we'll subtract a 2, okay? So we'll subtract an a, and we'll subtract a 2 to both sides of the equation. So this will give us 0 is equal to a squared plus 3a plus 2. And then how do we proceed? How do we find the solution here? So we want to use the property of 0. So we want to factor this. How do we factor that? Well, it's a monomial. So we know that the first terms are a and a. Plus 2, the product has to be 2, and the sum has to be 3. Well, that's only going to be 2 and 1. So that's not too bad. So then the solutions are what? Well, so right now, property of 0 says either this factor is 0 or this factor is 0 or both are 0. So we have a plus 2 equals 0 or a plus 1 equals 0. And then this would mean bringing the 2 over here, subtracting, we have a is equal to minus 2. A is equal to minus 1. So the solutions, those are the two solutions. So, or